Today we're going to discuss about refraction through a concave lens in physics chapter 2 optics. So you have studied about the convex lens refraction, how the image is formed. In convex lens you have studied 5 cases of image formation. So here in concave lens you're going to see only 2 cases. Okay, 2 cases and we will see it now. Before that you must know how the images are forming. Okay, so in concave lens this side is the object placing side, that is here we are placing the object, and here and in convex you can see the object is placed, but that is the object is placed this side and the image is formed by this side. But in concave the object and the image is formed by this side, that is the image only through this side. So the object is placed this side, the same side the image is formed. Okay, so we are not going to talk about this side. Okay, so before that, so this place, this is the infinity place, and this place we mark it as 1, position 1, and the distance between 2f and f we mark it as 2. So this is one case, and another case, that is f is considered as 1, and the between the principal focus, the f is called as the principal focus, and the optic center we mark it as 2. So okay, so we going to see in detail about the object at infinity. If an object is placed here, this is the infinity. Okay, object is placed here and the rays are passing, that is the light rays are passing to the concave lens. So this is the concave lens. What happened means, that is concave is a diverging lens, so it starts scattering. Okay, it starts scattering. So we are not going to form out, but it starts scattering. By scattering, it brings the image to this side, that is here in this position, and you can see the dotted lines on both the sides. Okay, so it's got scattering. Due to the scattering, we have putting the dotted lines where the image, this position in the principal axis, that is principal focus, the image is formed. So, and all the images in concave is virtual because it forms on the object side. Okay, so it's object side itself it is forming. We are not going to talk about this side, no. So there is no formation of image this side. So if the image is formed this side itself, so this side itself the image is formed. Okay, so that means the size of the image compared to the object, so the compared to the object size, okay, the image size is smaller. So the size of the image is small and virtual. So virtual means, so it will be, won't be clear. Okay, won't be clear, but the image is formed this side, that is object side itself, but it is virtual. Okay, so now you understood, no? So in the first point, that is in the at infinity means we can't able to find out where the object, that is where you are keeping the distances more. So here in the first case you are keeping the object in the first place, and you are allowing the rays to pass through the concave lens, and the image is formed in the first place, that is the principal, that is here the principal focus. So the image is placed in the first position. So the image is formed at the first position. How the object is placed at the first position. So here also first and here also first. Okay, next we move on to the second case. The object anywhere on the principal axis at a finite distance. So first one is infinity, but this one is finite, limited. So the object is placed between the curvature. 2f is the curvature and f, that is the focus, that is according to the first. Now the object is placed in the second position here. Okay, so it is in between 2f and f, that is curvature of the lens and the principal focus of the lens. You are keeping in between them, you are keeping the object. Okay, so this is the object, you are placing the object and the light rays passes through the lens, concave lens. So one is, this is the first rule, one is, that is, first rule is the one ray is passing through the optic center. Here it is the optic center, so there is no deviation. After refraction also there is no deviation. And the second one, that is the second ray is parallel to the, this is the principal axis, no, the middle line. So it is parallel to the principal focus, it is passing through the lens. So at the time, so the image has to form this side here. So the dotted lines denotes the image formation before f, that is the second position. So this is, you can see the image formation is, so we are keeping the object here in the second position and the image is formed in the second position in between the focus and the optic center. So in between the principal focus and the optic center, you are getting the image. You can see the dotted lines here where the image is formed. Okay, where the image is formed. Here also, how the image appears, small and virtual. Okay, so because why virtual means it appeared before, that is, it is appeared on the object side itself. So because of it, the size of the image is small and virtual. Now the distance between the object, you can see when the object distance, by placing here, this is the first object you had placed. So that means you get, in the first one you get a small image. Okay, when it comes nearer to the, so here you are keeping, no, so the size of the image, that is the last image, and the, this one is the last object, that is that you are getting the object closer to the lens, and the image formation, you can see it shows a large one. Okay, so it, when the object is far away, the image formation is small. Okay, but the distance of the object is decreased, the image, that is the image is also decreased, that is the image is, the distance of the object and the lens is decreased, means the image distance also and the lens distance is also decreasing. So the image distance, first you must know that the distance is decreased. Same way the lens and the image, so this gap is also decreased, you know. So the image distance, that is the object distance is decreased, means the lens distance between the lens and the image is also decreased. So how the size of the image, that is the distance is decreased, the object distance is decreased, means the size of the image, this is the size, you can see the small arrow, that is small arrow mark, and the larger, the size of the object, the size of the image is increased. So the object distance and the lens distance are decreased, means the size of the image is increased. So by decreasing the distance between object and the lens, the image size will increased. Okay, so now we are going to see the applications of concave lens, and the concave lens is used in Galilean telescope. So to view the stars, we are using this telescope, Galilean telescope. In that eye lens, it is made up of concave lens. Okay, and you can see the door. Indoors there is a small lens to view who is coming on that side, to know who is coming on that side. So that is called wide angle spy hole. In doors. There is you can able to view on the side by keeping a small lens. That lens is called concave lens, is used for the door, that is wide angle I spy lenses, that is used in doors. And a person has short sightness. Short sightness is otherwise known as myopia. If a person has a problem of myopia or short sightness, that problem can be corrected by using concave lens. By wearing concave lens, by operating the concave lens in the cornea, this problem can be this problem can be rectified. So what are the applications? They may ask in 2 marks. 2 marks. What are the applications of concave lenses? It is used in Galilean telescope as eye lens, and it is used as an wide angle spy hole indoors, and it is used to correct the defect of vision called myopia. So thank you for before going to this, explain the rules for obtaining the images formed by a concave lens with the help of a ray diagram. It is a 4-mark question. So only 2 cases no. So it is a 4-mark question can be asked from this topic. That is, next one, write the applications of concave lens. These 2 questions are important from this topic. Thank you for watching the video. If you like the video, give a thumbs up, share and subscribe to Science Easy Tech channel.